Hey, Topping Our Lives Math and History, and we are going to be learning about the speed of light. So in this video, we've been learning about the frequency, how much a wave passes in a given amount of time, and the wavelength, the distance between two crests of the wave. And you'll definitely see it like this format, 1 times 10 to the power of negative 18 meters. The negative 18 as an exponent represents that it's a very, very tiny wave. You can't see waves, only machines can. So the thing is, to calculate the speed of light, we have to go on hyperdrive mode. So prepare yourself for light speed.
Late! What happened? Where are they?
I don't know, sir. They must have hyperjets on that thing.
And what do we got on this thing? A Cuisinart?
No, sir.
We'll find them, catch them!
Yes, sir. Prepare ship for light speed.
No, light speed is too slow.
Light speed too slow?
Yes, we're gonna have to go right to ludicrous speed.
So here comes the first problem. If a wave with a wavelength of 8.25 times 10 to the negative 7 meters goes at the speed of light, what is the frequency in hertz does the wave have? So remember from the last video, we learned about the frequency. We're trying to find the frequency, and hertz is the measure of units of how many waves are going through a given amount of time. So what we're trying to do is, if the wave is moving at the speed of light, what is the frequency? How many waves are actually going through that time at the speed of light? Well, to understand the thing, there is an actual formula that we're going to learn about. The formula is, the speed of light is going to equal the wavelength multiplied that by the frequency, where this upside down y represents the wavelength and v represents frequency. Turns out that the letters are running out to come up with new formulas. So we already know what the wavelength is, and that is 8.25 times 10 to the negative 7 meters. That's how big the distance between this and this are. But the problem is, we do not have the frequency. But we do have the speed of light. Even though the problem doesn't give it to us, the speed of light is actually a constant, just like Avogadro's number, or pi, or tau, or some other numbers like E, or the golden ratio. It's always going to be a constant. And it's saying that the speed of light is going to equal 3 times 10 to the power of 8 meters per second. So if you visualize the speed of light, it would be speeding at 3 times 10 to the power of 8 meters every second. Nothing in today's technology of 2023 has never gone this fast before. Now, going back to the problem, we have the speed of light and also meters, so we can write as the formula 3 times 10 to the power of 8 meters per second is going to be divide that by 8.25 times 10 to the negative 7. The reason why we did that is because if we wanted to find the frequency, v, we have to set up a literal equation. So the speed of light is on the top, and the wavelength is on the bottom. When you solve for it, you should have a wavelength the size of 3.64 times 10 to the power of 14 hertz. So if this wave was speeding at the speed of light, this is how many waves, or this is how many hertz that would pass every second in a given amount of time. So that is how we solve for the frequency. That's if we knew what this was, and we knew the speed of light, but we did not know what v is. So that is the first example.
They mobilize to investigate the planet, which they name PNF 404. Kopai's last hope rests on 3 intrepid explorers. At last, the explorer's 279,000 light-year voyage nears its end.
Now we have another example. We are not at our destination yet. We still have one more problem to solve. So, if a wave with a frequency of 5.4 times 10 to the 14 hertz goes at the speed of light, what is the wave's wavelength? So, instead of finding the frequency, we need to find the wavelength instead. So, here's what's going to happen. Remember, the speed of light is going to be 3 times 10 to the power of 14. No. I meant 3 times 10 to the power of 8 millimeters per second. Maybe I should go down from Linger's speed to just light speed. Now, if we now know that that thing is a constant right there, then, wait, we already know the frequency. We have to divide 2 numbers, just like the last problem. And if we can make a literal equation, that would help us as well. So it's going to be, the speed of light is going to be divided by the frequency in order to get the wavelength. So the thing about that is, if we wanted to, we have to do is the speed of light, divide that by the frequency will bring you the wavelength. So we know that the frequency of the wave is at 5.4 times 10 to the 14 hertz. That's how much that the wave, how many waves are passing at a given amount of time at the speed of light. So the thing is, we already know that the speed of light is this. That is going to represent our C. Our frequency is going to be this. And that is going to be in hertz. And when you solve that, our wavelength is going to be 5.5 times 10 to the power of negative 7 meters. So that is saying the wavelength is very, 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 very small. You can't see that with the human eye. You can't even see wavelengths unless it's like the ocean. The thing about that is this, even though it looks very small, it goes from here to there. That negative exponent is saying that's a very small number. So that is how we find the wavelength if we were given the speed of light and also the frequency.
Ludicrous speed! Go!
I hope this video has helped you understand the speed of light. We have reached our destination planet, and now we can safely land on the planet. I hope this video has helped you understand the speed of light. Once you mastered the skill, then you can build your own spaceship and go at the speed of light. Thank you for watching Kyle Penalized Math Industry. Like and subscribe.